Welcome back to another episode of Math with Dr. Math. And it'll probably help if I put the mic closer. All right. So, attempt 3. Let's get, here we go. All right. So to do this, what we're going to do is we're going to multiply our coefficient with our coefficient. So that negative 9 times the 4 gives us what? Good. Negative 36. And then we have x squared and x to the third. So what are you going to do with those exponents? Good. Add them. So we got x to the 5th power. Good. And then you have y to the 4th and y squared. So that's going to give us what? Good. Y to the 6th. So when we're multiplying these monomial times monomials, that's essentially what we're doing. Any questions there? Any questions at home for those of you watching? No? All right, great. So let's continue. So now we have a monomial times a polynomial. All right. So what are we going to do here? Good. Distribute. So we're going to distribute this monomial, and it's going to get multiplied times every single one of these terms. And in the parentheses, you have what type of polynomial? Good. A trinomial, because we have 3 terms. All right. So let's do this. So when we multiply the first term times the first term, we end up with what? Good. 8x to the 5th y. Hello, sir. Welcome to YouTube. Okay. So we have 8x to the 5th y. What's our sign? Minus. All right. Go ahead. Continue the march. 6 y squared. All right. 6x to the 4th y squared. Excellent. What's my sign after that? Minus. Let's see how this works. I got to be careful with my buttons. All right. Minus. Go on. Bam. 16x cubed y. So again, you're just multiplying this monomial on the outside times each term on the inside. So it got multiplied there, there, and there. So what this turned into, essentially, is this turned into basically 3 of these problems right here. Yeah? All right. Let me move to the side. Some people are still copying. All right. Questions on that example right there? No questions? All right. So far, so good. All right. So this next one, we got a polynomial times a polynomial. Notice, all these are polynomials because polynomials just means what? Many terms, right? More than one term. All right. Various ways of doing these. All right. So I'm going to walk you through a few examples. Then you're going to get to choose. Okay. So this first example, this first method I'm going to teach you was first invented in 1876 by... No, I'm just messing. All right. So people are like, oh, tell me more. All right. So we have x times 3x squared. What do you get? Good. 3x cubed. And then we have x times negative 4xy. So what do you get? Good. Negative 4x squared y. Perfect. And then we have this x times this 5. What do you get there? Good. And it's positive, so 5x. Excellent. All right. Questions on what we did there? All right. Let me erase that. Let me get a different color going on. All right. So notice we distributed that x to everything. What do you think we're going to distribute now? The 2y. Excellent. So let's go ahead and do that. 2y times 3x squared y. 6x squared y. Notice how I put it, because look what's going to happen. See, I'm trying to line things up. You don't have to be this fancy, but if you want to be, that's cool. All right. Then you have 2y times negative 4xy squared. What did you get there? Good. Do we see one of those terms around? No, so I'll put that off to the side. I don't know if you guys have that much landscape on your paper, do you? It'll fit? Yeah? All right. So we said negative 8xy squared. Yeah? Excellent. And last but not least, we have 2y times 5 plus 10y. Excellent. And now we can go ahead and combine like terms. But how many terms are alike? Well, just these two right here, right? All right. So what's nice about this is this 3x cubed is going to drop. All right. So you end up with 3x cubed. You have negative 4x squared y plus 6x squared y. So you end up with what? Good. Plus 2x squared y. What's going to happen with this 5x? Good. It's going to drop it like it's hot. Bam. And what happens to these? Same thing. Good. They didn't have any like terms, so that is your final answer right there. Some of you may like that method. It's up to you. That's one of our methods. Yes.
And then if you want to like put in from the greatest to the least, if you already do them, like that is fine. Doesn't matter the order.
Good. So she's asking, do we need to put these in descending order, right? Great question. For these polynomials, because we're multiplying in such a way, see how, what degree does this have? So this is degree 3 right here, this guy right here. What degree is this second one? Careful. 3, right? Because what do you do with those exponents? You add them. So this is degree 3 also. What degree is this guy? 1. What degree is this one? 3. And when this one, we call it sleepy. And this one is, what's the degree here? 1. All right. So because it's all messed up, I would let this one slide in terms of the descending order. But for most cases, yeah, we'll put them in descending order. We're gonna see, when descending order might benefit us. Most of the time, it's gonna benefit us. But there's gonna be some times where we're gonna have to mix things up. And again, you're gonna see how to play this game as we move along. So, great question. I'm sure a lot of you guys in TV land were wondering as well. All right. So continuing the march, I'm gonna show you not a new method. I'm gonna show you a different method that some of you may know. This is called our box method. How many of you guys seen the box method? All right, so a few people. Cool. So let me introduce some of you guys to this box method. So what I'm going to do is I take any of these polynomials, right? Doesn't matter which one, and I'll put one on top. Notice I left out the signs. All right, so let me do that. And then I put my box. And then my other polynomial, which is a trinomial, I'm going to put it vertically. So I got 5x squared. I got negative 4x. And I got negative 8. So make sure you keep those signs in front of them where they belong. So don't lose a sign. All right. So now this becomes like old school multiplication where we do 3x and 5x squared. It becomes a 1-on-1. So what's 3x and 5x squared? 15x cubed. Great. And then we have 2 and 5x squared. What do we get there? 10x squared. Good. Then we got 3x and negative 4x. Negative 12x squared. Excellent. That should be a negative sign. Sorry. And then we have 2, and then we have negative 4x. So what do we get there? Negative 8x. All right. Then we have 3x and negative 8. So what do we end up with there? negative 24x. Awesome. And last, we have 2 and negative 8. Negative 16. I'll tell you why I like this box. All right. Because usually it means I'm going to get a present. But otherwise, what do you notice about these two and these two right here? They're like terms. It kind of keeps things organized. Then I don't have to go hunting for all the like terms. They're pretty well organized. So when I write my answer, I have 15x cubed. All right. Then what's going to be my x squared term when I combine these two? Negative 2x squared. Good. What's going to be my x term when I combine these two? Negative 32x, and then minus 16. And what's also nice about this, it's already in what? It's in descending order, right? So again, how many of you like this method better? So again, everyone's gonna go their own path. So whatever one makes sense to you, please use that method. All right, so there's some options for you. All right, questions so far? All right, go ahead, flip that page. I'll flip mine. All right, so we are going to look at special products. Everyone's probably, I shouldn't say everyone, but a lot of people heard of the FOIL method, yes? Except too many people misuse it. They say, oh, I'm going to FOIL, and they start talking about stuff that can't be foiled. All right. So everyone's like, oh, I'm going to FOIL this, I'm going to FOIL that. I was like, no, you're not. All right. So you could only use this FOIL method when you have what? 2 binomials. So a binomial times a binomial. Okay. So here's what the method says that right there in your notes. So it says the first times the first. So you have the first times the first. So you end up with what when you multiply that? Good. 8x squared. And then it says the outside and the outside. So the 2x and the negative 3. So what do you get there? Minus 6x. Then it says the inside and the inside. So let me go ahead and erase this piece. So now we're going to do the inside and the inside. So the negative 5 and the 4x. Minus 20x. Good. And then you have the last and the last. So the negative 5 and the negative 3. Plus 15. All right. And now you go ahead and notice I shouldn't use blue again. And so we combine our like terms and we end up with 8x squared. What's in the middle? All right. Minus 26x and then plus 15. And that's using the FOIL method when you have a binomial times a binomial. The only thing I don't like about it is it makes people think, oh, I have to do it in this order. To be honest, you could do in whatever order you want and you'll get the same answer as long as you do it correctly. Right? So I can make a mess of this. Right? Let's look at example 2. That's a nice thing. I could do y times 3x because I'm feeling a little crazy, right? So y times 3x, bam, 3xy. I could do y times negative 7y, and I get negative 7y squared. Right. I could then do 2x times negative 7y. So notice I'm just going all over the place. Negative 14xy. And then I could do 2x times 3x, which gives me what? 6x squared. And now I clean things up and I notice these two terms right here are like terms. So when I put things in a different order, I could write the 6x squared first. These two right here combine to give me negative 11xy. And then I have that 7y squared floating around and it's negative. So again, the whole point of this, when you're multiplying, just make sure this term gets multiplied times all these. The order doesn't matter. Make sure that this term gets multiplied times all these. The order doesn't matter. That's the only point I'm trying to illustrate here. Okay? So as long as you make sure everything gets distributed, you're going to be just fine. All right. Questions there? All right. And then someone's probably thinking, well, how do I know I'm done? So how do I know I'm done? Because the big question in math is, how do I know when to stop? So there's no more like terms. I can't simplify any further. There's no more like terms, right? So again, sometimes I'll see some beautiful work and I'll see this on the test, and at the end I'll see like 7. Hey, where the hell did that 7 come from, right? So again, just go as far as you can. All right. So we have two formulas. So you have a plus b squared. All right. So let me go ahead and do it the long way and show you what these formulas are. So when I say squared, don't write this down. This is a question for you. Is this the same thing as a squared plus b squared? No, right? But that's the most popular answer on the test. All right. So good. That's not the same thing. So I need to do what? A plus b, parentheses. Good. I need 2 copies. Right? And now I could do what to that? Now I could FOIL that. Good. So after you FOIL and combine your like terms, because you have to combine your like terms at the end, right? So after you go through that whole progression, what you end up with is a squared plus 2ab plus b squared. I don't have enough screen room to show all that, but we're going to use this real soon so you guys could see it for yourselves. All right, so there's our formula right there. And you're more than welcome to whenever you want to use that formula, it could save you some time. All right. And then the same thing's going to be true here. A minus b squared. A minus b squared. So let me do that. You're going to get a minus b. You're going to get another a minus b. And then you're going to do what to that? So good, you're going to FOIL that. So you're going to get a squared minus 2ab plus b squared, because a negative and a negative is going to give you a positive. All right. So what I want you guys to do now is I want you to try number 1 and 2. All right. And then check in with your neighbors. And I'll pause the video here. All right. So next page. I forgot to hit record. This formula right here. Anybody know the name of this formula? Oh, wait. Damn, I dropped the mic again. Yes, difference of squares. Difference of squares. Good. So the difference of squares formula, here's the trick. Whenever these terms are the same and these terms are the same, then be on the lookout for the difference of squares. But what has to be true? What else has to be true? The signs. The signs have to be what? Opposite. The order does not matter. The order does not matter. All right. So the difference of squares says you have a squared minus b squared. All right. So here we have a squared minus b squared. And you could FOIL that out if you want to prove it. But we'll just see that. We'll trust that it works. All right. So let's use that formula. So according to this formula, Can I use the difference of squares formula for example 1? Yeah, because the terms are the same and the signs are opposite. So according to this formula, I take this first term and I square it, so I get what? X squared. I take that second term and I square it, and I get 16, and the sign always in the middle is minus a negative. Good. So let's do the same thing with problem number 2. We take that first term and you square it. So what do you get when you square that? 9x squared. Good. You take that second term, you square it. 25y squared. Good. And the sign in the middle, always a minus. So you could use this formula whenever you have the same terms, right? So our terms were the same. 3x, 3x, 5y, 5y, and then you got a plus and a minus. The order doesn't matter on that plus and minus. All right, questions there? All right, let's talk about multiplying functions. All right, so essentially what we're going to do here is we're going to do the same exact thing. The only new thing is language. All right, so let's be careful with our language. I heard some F-bombs earlier. All right, so here we have F and G. No, we have F and G. So F and G, what do you think this is telling us here? Good, you multiply. All right, so this is the same thing, which as you see right here, is f of x times g of x. So excellent. So all that tells us that we are going to do is we're going to multiply the functions f of x times the function g of x. So what is f of x? X squared minus 4. All right. And then we have g of x. Uh-oh, some of you just saw the little red dot. Oh, shit, we're live. People getting nervous. So g of x is 3x plus 2. Let me take that down. It's really bothering some people. All right. And now we do what? See, people got camera shy. Yes, we FOIL. So we FOIL this. So go ahead, FOIL it. Let's see what you get. All right, even if you're not done, help me out. So we get x squared times 3x is what? 3x cubed. Good. How about x squared and 2? 2x squared. Good. We got negative 4 and 3x. Negative 12x and negative 4 and 2. Minus 8. Excellent. All right, so let me change colors. And any like terms here? Great. So that means you're done. So you're not always going to have like terms. You are not always going to have like terms. So wait a minute. Number 2, it looks pretty similar to what we just did, but what's different? Good. So in your homework, when you had the 2 in parentheses, what'd you do with that? Plug it in. So this 2, that's all you're going to do. Plug it in, plug it in. A word from our sponsors. All right. So we go ahead and plug it in. So we get, let me use a different color. We're going to get 3 parentheses cubed. Make sure you use those parentheses. Plus 2 parentheses squared. Let me move this to the side here. Let's see. Minus 12 times parentheses. Minus 8. And you told me what's going inside parentheses? Good. So go ahead and stick that 2 in there. 2 there, 2 there, 2 there. So this is why you practice all that in your homework. So do I multiply first? 3 times 2? Because I saw a lot of people doing that. No, but it's tempting, isn't it? It's very tempting. So don't be tempted. Exponents first. Exponents first. I don't care what your best friend told you. Exponents first. All right, we'll go ahead and multiply those. Minus 8. All right, so now you could go ahead and multiply those because we have no more exponents. So we have 24 plus 8 minus 24 minus 8. What's nice about this? Good. Everything cancels, so you're left with 0. But some people, they see this on the test and like, oh, shit, what do I do now? It's just 0. 0 is a number, so it's okay. Excellent. Questions, questions, questions. All right, make sure you subscribe. Problems that you're going to try. They're found on this page. So you're going to do these problems. You're going to... All right. Section 5.3, we're talking about the greatest common mother factor. And we're going to talk about factor by grouping. All right. So first of all, let's get some terminology because people, they always come in here with the wrong idea about factoring. So this word factoring here, you could think of it like this. All you're doing is you're turning something into a multiplication. All right. So when you turn something into a multiplication, you could think, oh, I'm factoring. All right. And that idea right there is going to help us as we move along here. All right. So let's read here just to make sure we understand. So factoring a polynomial is a process of writing a polynomial as a product. What does that word mean, product? Good. You're writing it as a multiplication of other polynomials. Okay. So it doesn't say you have to have one multiplication. You could have 2. You could have 3. All right. So don't get used to just one idea of factoring because people think factoring is just one thing. No. So this is what we've seen so far. We've seen something like this, and what did we do here? If we saw something like this, what is this telling us to do? Good, multiply, right? So what do you get when you multiply that? 5x squared minus 15x. All right. So 5x squared minus 15x. So that process is called multiplication, right? So when we go backwards, that process of going backwards, that's called factoring. Okay? So factoring is the reverse process of multiplication, just to make sure we're on the same page. All right? So let's go backwards here. Let's look at this example right here. And let's go backwards. So here, notice, they have a 2 in common. So when you factor out a 2, what are you left with in parentheses? Good. 2x plus 6, because essentially what you're doing is you're dividing both of these by whatever you pulled out. So I'm dividing each one of those by 2. That's what's really happening. All right. Can I get an O? Oh. All right. There we go. Here we have 4x plus 12, but what did we factor out here? A 4, right? So when I factor out a 4, I'm really dividing those by 4. So what am I left with? X plus 3. Okay. So that's going to help us tonight. All right. Because we divided both of these by 4. All right. So if a polynomial cannot be factored, because not every polynomial is factorable, then we say it's what? Prime time. Good. So if it cannot be factored, then you just write the word prime. You got to be careful because you're going to have a factoring test. And it never fails me. I think it's a joke coming into the class where I gave a test and then someone gave it right back to me and I just saw this all over the test. Prime. And I was like, hey, what's going on? He's all, well, I didn't know how to factor it. I was like, that doesn't mean you write prime, right? So just because you do not know how to factor does not mean it's prime. All right. Prime means it cannot be factored. All right. And you're always going to try to factor completely. So notice this. When I say factor completely, if we return to the example above, all right, this right here is not factored completely. Why is that not factored completely? I could still factor out a what from here? A 2. Does that make sense? So you always have to pull out the biggest factor, the largest factor. All right, this is America. We want the largest, the biggest. All right, so let's flip that page. Let's get some practice. All right. So we got the greatest common factor. We want the greatest common factor of each term. So make sure it has to be the same number if you're going to pull out a number. Same variable if you're going to pull out a variable. All right, let's look at this first one. What number can you take out of 15 and 5? 5. All right. Do they both have an x? So factor out the smallest x. Write that down. You factor out the smallest. And when I say the smallest, let's think of it this way. How many x's does this guy have right here? This one I'm pointing to. 2. How many x's does this guy have? 3. So would it make sense if I took out x cubed, would I be able to take out 3 x's from this guy? No, it doesn't have enough. So that's why I say factor out the smallest exponent. Make sense? Because you have to make sure they both have it. So with that said, you're also going to factor out y to what power? Good. Y to the 5th. All right. Then we put our parentheses because we're going to have something left over. All right. So let's figure out what's left over. So 5 times what is going to give us that 5 back? Think of me. Good. Number 1. All right. Notice I had 3 x's, but I took out 2. So how many x's do I have left? 1. I had 5 y's. I factored out 5 y's. So how many do I have left? Wait, let's try that again. I had 5 y's. I took out 5 y's. How many do I have left here? Okay, good. Bring the sign. All right, now we're going to talk about this next term, right? 5 times what is going to give us that 15? 3. This one had 2 x's, but you took out 2 x's. How many x's do you have left? None. They're gone. This had 7 y's. I took out 5 of them, so how many left? Good. So another way you could have done this or thought about this is you could have just divided both of these by the GCF if you wanted. You could have divided each one of these by the GCF. Again, we all think differently, so whatever makes sense to you, do it that way, right? Or like Burger King, have it your way. All right. Number two. Let's play with this idea again. Okay, now we have how many terms here for number 2? Now we got 3 terms, so we got to be careful. So 12, 4, and 8, what's the biggest number you could factor out from all 3 of these? 4. So I'll factor out a 4. I got x to the 4th, x cubed, x squared. So I could factor out a x squared. Smallest exponent. Good. Here I have y. Here I have y squared. Here I have y cubed. So I factor out a? Because I'm asking. All right, good. A y. And now I see what's left over. Yes, if you're watching, you heard that right. Their teacher's a dork. All right. So 4 times what is going to give us that 12? 3. All right. I had 4 x's. I took out 2, so I'm left with 2. Good. I had 1 y. I factor it out. So any y's left? No. That sign stays. All right. I had 4. Factor out 4. So what's left? What number? 1. Do you need the 1? No, we don't need it. I'll just write it. I like seeing it. I have 3 x's. I took out 2. I'm left with 1. Good. I had 2 y's. I took out 1, so I'm left with 1. Excellent. What's my sign? Positive. Go ahead, fill in the last blank, and let's see if we get the same answer. I heard a 17. I hope that was a joke. All right, what are you guys left with? 2y squared? All right, excellent. Does the idea make sense? All right, put it to use. Number 3, it's all yours. If you're watching, number 3 is yours. Go for it now. All right, we're back from our commercial. So let's ask the studio audience here. What did you guys factor out? 5 x to the 4th y squared. Good. So there's your GCF. Any questions on that most important piece right there, that GCF? All right, that very first term, what are you left with? Well, that's not 3, that's an imposter. Good. 3x squared what? Y squared. Good. All right, what's next? Minus y squared? No? Just y? Por y? All right. Minus y like that? All right, what's next? Plus 2x. We agree? All right, let's go home. Just kidding. All right. Part C. Part C. Factor the negative GCF from the polynomial. Why do you think we're going to factor out the negative GCF? Maybe we're in a bad mood? I don't know. So the reason we factor out a negative GCF is to make sure your leading coefficient, your leading term is what? Positive, because we're positive people, right? Good. All right. So you always want this leading term to be positive. We're going to talk about that, but that's a good thing to write down somewhere. We always want this guy right here that I'm trying to erase to be positive, that leading coefficient. We're going to see. Yes, Karina. 2x, but I ran out of ink. There. Thank you.
Say that again, what you said.
I ran out of ink there. Oh, that part. I always want this piece to be positive because I'm a positive kind of guy. All right, so let's factor out the negative. So what negative number are you going to factor out? Negative 2x. Excellent. All right, so let's pull out the negative 2x. What is that going to do to all our signs? Change them. Good. So what's this first term turn into? 2x squared. Perfect. What's this next term turn into? Negative 4x. Great. What's that last term turn into? Plus 3. Yeah. Excellent. And if you might notice, I made my parentheses a little too far. There. I like my parentheses like my shirts. Hugging. All right. So, number 2, try it. Try number 2. All right, we're back. What'd you guys factor out? A negative 2 or negative 2x? Negative 2. Why can't you factor out the x? Good. There's no x here to factor out, right? Some of us hung up on our x. All right. So what am I left with in parentheses? Perfect. We're all out of sync. Good. So x squared minus 8x plus 2. Is that what we got? Yeah. All right. Last page. Woo. All right. First. Here we go. Let's bring it home. So factor out the greatest common binomial from each of these polynomials. All right, so check it out. Each of these, let's look at number 1. They have what in common? They have y minus 4 in common. So before, when they had something in common, what did you do with it? So before, when you had something in common, what did you do with it? Good. You factored it out. Say that word with me. Factor it out. One more time. Factor it out. Good. Now we're talking math. So they have a y minus 4 in common. So what are we going to do with it? Factor it out. So we pull out the y minus 4. So check this out. When you factor something out, this might help us. First, let me see how much we understand without me doing the illustration. What are you going to be left with? X plus 6. If you can't see that right away, maybe when you see this, y minus 4, you kind of scratch it out. And then whatever you're left with, that's what you're left here. So again, however helps you think about this, make sure you have it in your notes. So whatever makes sense to you, write it that way. So here's the big question of the day. Is that factored? Yes, no, maybe so. What does it mean to factor? Turn into a what? Turn into a what? Multiplication. Is that a multiplication now? Yeah, so you have factored. You're all done. You are all done. We only factor that thing that's in common when they ask us to factor. Yeah. So how about number 2? Do they have anything in common? Yeah, right? They have same cousin. So what are you factoring out here? 2x minus 5. Ooh, be very careful here. Write down what you think's in parentheses. Go for it. I said write it down. Man, I'm trying to help these guys in our studio audience at home. Oh, no, I guess our studio audience will be here. I'm trying to help our audience at home. All right, what'd you guys say? Y minus 1. Where'd that 1 come from? Bam, right there. There's an invisible 1 right there. All right, excellent, excellent, excellent. All right, so this is going to be the key right here. What you just did, and you nailed it, is going to be the key to this last section. Probably my favorite section. Factor by grouping. Ask me why it's my favorite section. Go for it. Oh, thank you for asking. It's my favorite section because it's the last section of the day. All right. So, factor by grouping is used when a polynomial has how many terms? Man, you guys are good. It's like you have notes or something. All right. So it's when you have 4 terms. All right. And here's your steps, right? So step number 1, tie your shoes. Let's see. So there's your steps. We're going to group the terms that have a common factor. So what that means is this. They might not be in the order that you need them to be. So if you need to, rearrange stuff. You could always rearrange the polynomial. So if you need to put something at the end, go for it. So that's what step 1 tells you to do. Group the terms that have a what? Common factor. So that might mean that you have to rearrange stuff. In your homework, you're going to see that's crucial. Step number 2, factor out the GCF from each group. And it has to be the GCF. Not just the factor, it has to be the greatest factor. All right. And step 3 is best if I just illustrate it. Let me show you. All right. So our very first example, what we're going to do here is, let me give myself some space. All right, because I like Space Jam, so let me write it right here. All right. Who doesn't? All right. So what I'm going to do here is I'm going to group the first two. I'm not putting parentheses. I'm just going like that. I look at those first two and I ask myself, Johnny, what do those two have in common? Good, they have an X in common. Good. I was talking to Johnny, but that's fine. All right. And then I factor out the X and I ask myself, Johnny, what's left in parentheses? And then the audience would say what? Y minus 6, because they wouldn't understand I'm asking Johnny. All right. And then I look at these next two terms. And I look at these next two terms and I ask this time, class, what do those next two terms have in common? 4. And is it a positive or negative? Whoa, whoa, whoa. All right, here's a secret. Here's a secret. No, he likes to. No, I'm just kidding. Always bring down that sign in the middle. My bad. Sorry, I forgot. We're live. Act serious. All right. So we bring down that positive sign. All right, and if it was negative, we would bring down the negative. So you told me they have a 4 in common. Quiet, I'm recording. And then what's left in parentheses? Y minus 6. I'm going to pretend that's what I heard. All right. All right, great. Perfect. They don't know at home anyways. So what do they have in common? Y minus 6. Oh, shit. I see where this is going. And what's left over? X plus 4. You just factored by grouping. Congratulations. Call in order now. All right. Questions in that process? There's got to be some questions. All right. Number 2 is yours. Try it. Try number 2. If you're still with us in YouTube Lab, you try number 2 too. All right, so we're back and here's our problem. We're looking at this problem right here. And we're a little bit off the screen. All right, there we are. All right, so same idea. These two have what in common? X, so we factor out the X. What are you left with in parentheses? X minus A. What do these two have in common? 5. So is it plus 5? Good. Minus 5. You always drop that sign in the middle. That's going to be key as you're doing your work. And you have X minus A. Why is it X minus A? Good. So when you distribute this minus and the minus, it better give me what I started with, right? So notice, it was a positive, but you factor out a negative. So that always changes the sign. Good. What do they have in common now? X minus A. So I factor out the X minus A, and I'm left with X minus 5. Bam. Not so bad, right? Hopefully. Maybe. All right. Is that the last page? Yeah. All right. So what I want you to do is you could take a break